Today, we learn the concept potential difference from chapter Electricity, class 10. So before understanding the term potential difference, we simplify the meaning of this potential difference with water analogy. Let's say here we got two cases. In first case, assume that this is beaker A and this is beaker B, and two beakers are filled with equal amount of water, and they are placed on the same surface. So do you see any flow of water from one beaker to another beaker? No, right? The reason is they are kept on the same surface at the same level, so that there is no difference in the height of these two beakers, so that you won't find any flow of water from one beaker to another beaker. Now you can see the second case. Let's say this is beaker A and this is beaker B. Here also we have equal amounts of water in both the beakers, but a beaker B is kept at a certain height. It is kept at a certain height. That is, the beaker B is kept on the ground, and let's say beaker A is kept at a certain height. Now, in this scenario, you can see that the water will start flowing from beaker A to beaker B because of the difference in the height of the beakers, right? Yes, that is what we are considering it as a potential difference. When there is a potential difference between two ends, then the charges also will flow like water from one point to another point of the conductor. Let's see how. Now, assume that this is a conductor, okay, and a charge, a unit positive charge. This is a unit positive charge. It is moving from one end of the conductor to the another end conductor. How it is possible? It is possible by connecting this wire to the power source, that is battery. The battery will provides the potential difference in a circuit. That is, high potential of a battery is a positive terminal, and low potential of a battery is negative terminal. Here you see that a positive charged particle will start to move from high potential to low potential. It is all due to the difference, potential difference across the conductor. So when this positive charge move from one point to another point through the conductor, we can say that there is some work done on the charge. That is, the work is done to move the charge from one point to another point through the conductor, right? It is all due to the potential difference. I hope you understand the thing. We see the definition for this potential difference, how we can define the potential difference in much better way. So when it comes to the definition of potential difference, the amount of work done in moving a unit positive charge from one point to another point in an electric field, that is through the conductor. As in the previous slide, we have seen that because of the potential difference across the 2 points in the conductor, a charge will start to move from high potential to low potential. This is what you are calling as potential difference. So the mathematical expression for the potential difference is taken likewise. V is equals to W by Q, where V is the potential difference, W is the amount of work done in moving the charge, and Q is the charge that moves through the conductor. That is, V is equals to W by Q. Potential difference is equals to work done on unit charge. Work done on unit charge to move it from one point to another point. That is the mathematical expression. And the SI unit of potential difference is volt. Volt. It is represented with the letter capital V. And to measure that potential difference across the conductor, we need a device, right? So the device used to measure the potential difference is voltmeter. And this voltmeter is always connected in parallel connection. Why it should be connected in parallel connection? Because of its high resistance. Because of its high resistance. As it has high resistance, if it is connected in series, sure, it will opposes the flow of electric current, so that it affects the flow of electric current through the circuit, so that voltmeter should always connect in parallel connection. Then now we see a numerical on this concept. Question 1. A charge of 2 coulombs is moved from a point A to point B in an electric field if the work done in moving this charge is 10 joules. Calculate the potential difference between the 2 points A and B. So here the charge, what they have given is 2 coulombs of charge, right? 2 coulomb of charge is moved from one point to another point. And to move that charge, what is the work done on it? 10 joules. 10 joules. So what you need to calculate? You need to calculate the potential difference. What is the potential difference to move the charge from one point to another point? Okay. So what is the formula that we use? V is equals to W by Q. So plug in the values, what we got. Work done is 10 joules, right? Whereas the charge is 2 coulombs, 10 by 2. 2 ones are 2 fives are. So what you got finally? 5. The unit is volts, 5 volts. The potential difference across these 2 points to move the charge is 5 volts, right? And next, we see one more numerical related to this charge. Question 2. How much work is done in moving a charge of -5 microcoulombs from point where the electric potential is 10 volts to another point where the electric potential is -2 volts. Here we know that micro, what is the value of micro? 10 power -6. So here they gave a charge. Let's say the charge Q is taken -5 microcoulombs. Micro, what is micro here? 10 power -6 coulombs. -5 into 10 power -6 coulombs. And we have two electric potentials that they have given. Let's say this is point A and this is point B. So the initially, what is the potential here at point A? The electric potential at point A is 10 volts. The electric potential at point B is -2 volts. So a charge should move from point A to point B. Okay. Yes, there is a difference between the potentials between these 2 points. Between these 2 points, we have a potential difference, right? We need to find the potential difference first. So let's say the initial potential is taken as 10 volts, whereas the final potential is taken as -2 volts. That is, initially the charge is at A and it is moving to point B. So that I'm considering this as a final potential and it is an initial potential. So how you are going to take the change in potential then? Delta V is equals to final potential minus initial electric potential. That is, what is final potential? -2 minus 10. So what is the potential change in potential that you got? -12 volts, right? So now we got the potential difference. What is potential difference? V is equals to -12 volts. Now we need to find how much work is done in moving that charge. So we need to find how much work is done in moving the charge. So first, what mathematical expression that we use? V is equals to W by Q. So it can be further taken. W is equals to V into Q, right? So what is V here? Minus 12 volts into, what is the charge? Minus 5 into 10 power minus 6. So minus and minus, minus into minus, plus 12 5 is a 60. 60 into 10 power minus 6 joules. Also can be taken 6 into 10 power minus 5 joules, right? So this is the work done to move a given charge across the conductor with two different potentials, right? This is the work done to move the charge. 6 into 10 power minus 5 joules. Clear?